Hello everyone, I'm Ming-Chi and this is the video explanation for homework 5, question number 2. In this question, we are given this formula for fxy equal to a is constant, and 1 over a y squared x, and we're also given that the constraints that x and y each have. And the first small question is to find out the non-zero definition region of fxy. And here's the solution for that. We know that y is larger than 1, so it's above this line. This line is x, this point is 1, 1. Right? This point is 1, 1. And so for y larger than 1, it's basically for saying that every value above this line. And we also have that x is smaller than y, larger than 1 over y. So we can disassemble this this part over here to as x larger than y, or 1 over y, and x smaller than y. It's basically telling us that this is the line of y equal to x or x equal to y. So anything that's x smaller than y is over that side, over this side. And for this part, x larger than 1 over y is this is x equal to 1 over y, or y equal to x, or 1 over x. So x larger than that is saying that this part. So the intersection between the two parts, the two parts that we talked about, is this part, and is the shaded area is the non-zero definition region. And for question part 1, it's solved. And for part 2, we need to find this a values. We said that a is a constant, but in order to make it a valid joint density function, joint density function should also have should also be that, like this: f x y is integral should be equal to 1. And with that in mind, we can just go and solve it. We have here y larger than 1, x smaller than y larger than 1 over y. We have this is equal to 1, like I said. And here it's basically doing the integration first over x and then over y. This entire equation should be, this entire part should be equal to 1. And keep doing so. We can take this dx in here, and whatever is not relevant to x, we can take it out like that. And we just do the integration over x for this part and represent it in y. And notice that we have ln y minus ln 1 over y. The minus ln 1 over y is exactly the same as positive ln y. So we have here ln y plus not ln y is basically just, we have a 2 like that, and we can take this 2 out. We can have this, and ln y is remaining inside, and we can do the integration over y for this part, and the entire thing should be equal to 1. And for the integration of this part, it's already equal to 1, and it's over here. And the 2 over a times 1 equal to 1, we have a equal to 2. That's the value for a. Oopsie, annotate, clear openings. Okay. For part 3, we were to find out the marginal density functions for fx and fy, and find and draw. So basically, we already have the a value. We put it in here. We have the joint density function over here, and we want to find fx. We need to do is to do the derivative. Oh, sorry, the integration of this over dy over y, and for finding this part, we do the integration over x. So basically, that's what we do here. For y, it's relatively easier. It's just plug the 2 in here and just do the integration. We have this value here. This is not minus. There's no minus here. It's just this function. This function is the what's this called? Yeah, marginal density function. And by plugging this equation in the graphing calculator, we have the graph like that. So yeah, just starting from one, a shape like this. For fx, is a little bit different. We can discuss it in two regions as x smaller than 1, larger than 0, and x larger than 1. To do the integration over that separately, we have for this region, it's a constant 1 over is 1/2, and for this region, we have this equation. We can also do the plug this in and using the calculator, but we already know that it looks like this. It's this part, and for this region, it's just a constant value. It looks like this. And for part 4, we are basically trying to just confirm. It has to confirm that fx and fy are valid functions. So in order to do that, we just need to check that their integration is equal to 1. So the dy part, this x really should just be an infinite. And this part after the integration is 1. We can confirm that. And this part, integration over x plus this part is 1/2. And this part is also 1/2. So it's also 1. The combination is also 1. So both are valid. And that's it for this question.